Alright, you're most welcome once again, ladies and gentlemen, students, colleagues, who are there, sisters and brothers, and my daughters and sons, you're most welcome. Today we want to continue to look at the complex numbers as we said, but last time we had introduced something about it. Then, for today, I promise you that we shall start from the general part or the general form of the complex number. We want to know how does it appear, right? And in case you have known that, how do you use it? That's what we want to see today. But before we continue, subscribe for you to be able to get the updates that I will be uploading. Secondly, you can send me a message OS, WhatsApp me OS. Just call me on 0758876705 for any question that you may want to ask OS if you have any inquiry. Then you can send an email just in case you can use an email, sokasan07@gmail.com. You can pass via that. Yes, we shall not waste my time. Let us look at the general form of the complex number. Let us look at the general form of the complex number. How is it presented? The general form of the complex number. Let Z be a complex. Let us say the complex is related Z. Let us assume that Z is a complex number. Let Z be complex number. So if Z is a complex number, it will be given by Z equals A plus BI, or Z equals X plus YI, or Z can be equal to A plus MI, depending on letters. But A, where A and B are real numbers. You know what we mean by real numbers? It can be, if we are here and here, we talk about X and Y are real numbers. You know, if the number is not real, then it will be complex. That's what we mean. So in this case, what are examples of real numbers? 2, 1, 3, 4. Those are the real numbers we are talking about. So if you have a number like 2i, now b will not be equal to 2i. 2i now is a complex number. We shall know the reason why. We are saying that in case when we talk about a and b being real numbers, it means that they are what? Those numbers too, they don't have that property I. Okay? The property I equals square root of minus 1 works for complex numbers in that case. So you are saying if this is the general part of the complex number, we are saying that the complex number has two parts: the real part and the imaginary part. The imaginary part. What is the real part and what is the imaginary part? If this is the complex number we are considering, Z equals A plus B and A becomes the real part. The real part of that complex number, then B becomes the imaginary part of the complex number. The one with I, the one with this property I here, or with this symbol I, becomes the imaginary. Now, when we want to take the imaginary, we don't take the whole thing, Bi. The value of the imaginary part just becomes B. The I is just present to indicate that this is the imaginary value. So if someone asks for the imaginary value, you take a B. But this B can be any other value. It can be 2, it can be 3, it can be 4, as we shall look at the next. Now, if someone asks Z equals X plus Y, it means that X is the real part, Y is the imaginary part. that case y becomes the imaginary part. Now, after knowing this, we can look at examples of complex numbers that we see. We want to look at examples of complex numbers that we see. We are saying that this is z equals 2 plus 4i, then 2 you can have maybe 4 plus 3i, you can have 3 minus I, you can have complex number 4, negative 1 plus 2i. We are seeing these numbers here. All of these ones are complex numbers. Now, if someone comes and asks you for the real part here, you come and say that the real part for this complex number is 2, because this one doesn't have that property I. Then the imaginary part is 4, the one that has I. If we were looking for the real part here is 4, imaginary part 3. Real part here 3, imaginary part here negative 1. Let me hope you consider negative 1. You take the value with its symbol. With its symbol, the plus or minus. We are saying that when you look at this number 4 here, the complex number is this one. The real part, negative 1. The imaginary part, 2. Simple as that. Positive 2. Now, the question comes, what about if someone writes for me this one here? Just 2i. Someone just writes for me I. Or someone just writes for me I. Just that. 2i or I. In this case, it means that this person would come and say that, what if I have plus 0 here? I know that the real part is now 0 and the imaginary part is 2. Just that. Now, the same thing will apply to this one. By the coefficient of I here is 1, meaning the imaginary part is 1 and the real part is 0, because it is nowhere missing. You can just add that 0 to indicate that it is the what? Imaginary part. Then, what if someone writes this one? Just 5. That I have 5, or else that z equals 5. I have 5. You see that if I have 5, what does it mean? Is it still a complex number? You ask now yourself a question. Is z equals 5 a complex number? Because we say the complex number has 2 parts, the real part and the imaginary part. Is this one having the real part and the imaginary part? Here we say that this complex number has both of them, the real part and the imaginary what? Part. Now this one here is 0, the real part is 0, but it still remains with its real part and it is still a complex number. Even z is 0. Now even here, if I write z equals 5 plus 0i, still I have the imaginary part as 0. The imaginary part is now what? 0. So it is now a complex number but with 0 imaginary part. So in that case, what I said, this one here, this is a complex number which is purely real. It is purely real. And if it is purely real, what does it imply? That all real numbers are complex numbers. All real numbers can be complex numbers. Why? They have 0 imaginary part. If you say that, then you give me the imaginary part of the real number, I'll say that it's 0. So I can say. So all complex numbers, all real numbers can also be what? Complex numbers. We are interested in the real part. This one here has only the imaginary part, so it is purely imaginary. When someone talks about that the complex number is purely imaginary, we just say that the other part is 0. Pure. There's no impurity. Purely imaginary. The other part of the real is what? Is 0. That's what you should know always in that case. Now, I want to finalize today. By saying that all of these parts here, we shall consider these things here with them in the head. However, we shall begin by, the next step on this one will be about looking at the algebra of complex numbers. What do we mean by algebra of complex numbers? We shall be interested in addition, subtraction of complex numbers, dividing complex numbers, and also multiplying complex numbers. You looked at surds, you know what it means by dividing surds. So even here, you must know by the end of this, if you don't miss, you know how to divide complex numbers. What do we do when we are dividing them? What do we do when we are subtracting them? And what do you do when you are multiplying them, adding them? What do you do? So that's the concept I don't want to miss for today. I will end on this part here. At least I expect people to be having the knowledge of the general complex number in their heads, and at the same time I expect you to state the real part in case you find the complex number there, or else you can also find the imaginary what? You can also state the imaginary part such that everyone can know it. At this point of moment, I want to that don't move away when subscribing. I wish you the best, but 0758876705. You can pass via that and send me a message, WhatsApp, or else you can call. I wish you the best at this point of moment.